Okay, question 15. We're given a differential equation. This dy dx equals sine of x plus y. And we're given the slope field for the differential equation, and we're given two solutions. So these are the graphs of two solutions of the differential equation. Then it says the two solutions, for the two solutions given, the local minimum points lie on the straight line L1, right? So firstly, this is kind of a strange question, or an unusual question, let's say, but this is a minimum and this is the minimum, and he's saying these lie on a straight line. So the straight line that these lie on is this. That's the straight line. It goes through this and this. And he says find the equation of that line. Now you might hazard a guess at what that equation is, but I don't actually know what that point is, and I don't know what this point is. So I can't find the equation of the line using 2 points because I don't have any points. The only points I have are 0, 1, which isn't helpful, and the 0, 3 for this curve, which isn't helpful. But what I do know is it says for the two given solutions, the local minimum points. So it goes through these two local minimum points. And what do we know about minimum points? This is one of the first things you learn when you learn about calculus. Minimum points occur when the derivative equals 0. So let's write that down. At min dy dx equals 0. Write that down. You might get a mark for it. And then we go sine x plus y equals 0. And then we can say x plus y is equal to, now it's either x plus y is either equal to 0, pi, 2 pi, 3 pi, etc. Or, don't forget, negative pi, negative 2 pi, negative 3 pi, etc. Now I've stopped there and I'll show you why in a second. So that means the equation of this line is going to be y equals, so it's going to be y equals negative x plus 0, or plus pi, or plus 2 pi, or plus 3 pi, or minus pi, or minus 2 pi, or minus 3 pi. Because, well, it can be any of these for this to be true, for sine of x plus y to equal 0. Now, just by looking at this, that's really the only way we can decide what it is. But by looking at this, and I had a kind of, well, when I drew this line, I thought, well, this does look like y equals minus x. This line is y equals minus x. Because if I do y equals minus x plus pi, y equals minus x plus pi would be this line with a y-intercept of pi, which is 3.14. Now look, that's actually, let me copy and paste this line. That's actually going to be the answer to part B, because this goes through pi, which is 3.14. It's definitely not going to be, let's get another line here. It's not going to be one of the minus pi's, because that would be down here, or plus 2 pi would be up here. Those are the two solutions. So that's a y equals minus x. And then for part B, I can say y is equal to minus x plus pi, and that's it, because this is the one that goes through the two maximums, because part B says for the two solutions given, the local maximum points lie on the straight line L2. So this is L2, goes through here and here. This is definitely going to be the y equals minus x plus pi line, and this is the y equals minus x plus 0 line. Okay, that's it. I think once you see it drawn and worked out, it's not so bad, but definitely the first time you see that question, that's a difficult one.